my deputy directors, distinguished colleagues from Europe and Asia and Georgia as well, dear participants, ladies and gentlemen, I would like to welcome you all to our GreenChemMap conference. Before beginning, I would like to invite you to attend our Turkish national anthem and 1 minute of silence. Please rise up. Thank you so much for your participation and patience. Welcome again to our program, which is an output of an European Union K2 project. The project's name is, as you might know, the GreenChem project. And now, I would like to invite the academic coordinator of the project, who is Associate Professor Dr. Mustafa Kemal Gümüş. Okay, as a beginning, we would like to short introduction and information about our project, our European Union project. As you might see on the slide, the full name of our project, Green Chemistry Applications on Selected Medicinal and Aromatic Plants in the Artvin region. Project overview. It was, as I mentioned to you, it was a K Action to Higher Education Institution projects, cooperation partnerships in higher education. You can see our number, and it has been almost 20 months, I guess. We have been working together with the project participants, and it's going to be ending at the end of this year. So this is the closing conference for the project, and I do very much hope we will be seeing perfect results for the project. Our project tackles climate change, public health, and environmental pollution by focusing on medicinal and aromatic plants through international workshops and expert panels. It aims to improve the plant cultivation, foster academia-business collaboration, and support regional development. The project will also prevent endangered plants from extinction and promote their transformation into valuable products. Running for 24 months, it follows a strong sustainability plan under the coordination of Artvin Çoruh Üniversitesi. By the way, we have other distinguished partners for this project, as you might know. The first project partner is from Romania. This is the University of Galati. And the second partner, University of Chemistry and Technology of Prague. And the third partner, University of Turin. and the other partner is a single Christian institute from Ukraine, and the last but not the least partner is from Georgia, Agricultural University of Georgia. You can see all project partners on the slide. And again, we have participants from all from our partners, and I would like to welcome you all again to our country, to Artvin again. Yeah, this is our fourth project meeting. The first one was held in Turin under the leadership of Professor Giancarlo. I'd like to thank him again. That's like an initiation meeting for our project. And mostly Mustafa Kemal Gümüş, hocam, would you consider to go on the project with this?
Yes. Thank you. Yes, our first meeting, it was last year, last May, as I remember, in University, in Italy, in University of Turin, and we focus for this workshop, especially for green extraction methods with Torino group. Professor Gravotto, one of the most important and good scientists about this field, and he was there about 5 days, with all partners, and we visited their laboratories. Also, we made some workshop, and also that time we start introduce our plant. Because of that time, we couldn't collect our plants. Last, it was in May. In summertime we started. Last summertime we started to collect our plants, Ruscus and Hypericum.
Thank you so much. And you know, project objectives, as I mentioned, focus on medicinal and aromatic plants for economic growth and healthy living, and also combat climate change, improve public health, and address environmental pollution. That's our overall projects or aims for our projects. And of course, we did not only visit the partner universities, especially our project team has worked a lot in laboratories on the field, right? Maybe you can give us extra information about that factors.
Thank you. There's two photos. First, left one is from our university's laboratory from summertime, our first extraction time. Dr. Aromatik and me was here, but I wanna say thank you for all our team because of before also we determined with my college went and collect plant and make here we will make here classical subset extraction. And also we sent our plants this summer to Turin to make subcritical extraction, methods, and we combined two different, of course, both one is one of molecule and one of classical way of extracting connector, and we sent we and Turin sent this extraction to Bitkilerde University and to Agriculture University to Bizi. And the second photo is from University of Turin Laboratory, or from first meeting.
So as promised, all extractions and all Hypericum and Ruscus samples have been analyzed in different laboratories in different countries, as promised under the framework project. Thank you very much. And this is, and I'd like to mention the name of our rector, Professor Dr. Mustafa Bizi. Thankfully, he attended the first meeting in Italy. He was with us together, and I would like to thank him for his support and contribution to the project. So for the project's key activities, so as I mentioned, we did project meetings. We also focused on target plant samples, and they were identified and collected from the field. Extracts were obtained from all relevant organs. Extract samples were sent to the relevant project partners for bioactivity steps, and preliminary studies required for chemical analysis studies were completed. And before forget, and with permission for our international partners, I would like to thank our project team in Turkey, who are Associate Professor Dr. Funda Erşenbak, Associate Professor Dr. Emrah Peşman, Dr. Mustafa Umut Konanç, and Dr. Ergün Gültekin. They all helped and contributed to the project with all the scientific work and labor. And I would like to thank them all again with your presence. Okay, now the photos from meetings. And our coordinators here.
After first meeting, it will be second meeting. It was in Galati, Romania, in last September. And from this time, we discussed in this meeting about our preliminary results from Galati and Bizi work. And during this time, until September also, we collect Ruscus, not Ruscus 1, and send all partners. We discuss, especially here for biology, activity aspect, and antioxidant and anti-cancer facilities. We discussed in this in Galati meeting. And we also, after this September, we sent all Czech Republic partner and Ukrainian partner or samples for analytical properties and for determinations of compound from extract.
And yeah, this is the field work by our professors.
Yes. Dr. Emrah Peşman and Funda Erşenbak hocamız.
They are collecting the samples from very nature, very hard of the forest. So it was a great work, so thank you again. And yeah, they're delicately electing the materials. So.
They are Ruscus.
Yeah, right.
Also, and me also joined them, but there is no photo. But we will see.
Okay, but the machines, so you were working on these machines.
Yes.
Okay. So, the key accomplishments: successful collection of processing of plant samples, and knowledge transfer and training sessions held in Italy and Romania, as you mentioned during your speech, Professor. You're gonna contribute something there?
Yes, we didn't. Maybe we will talk. I think next chapter. Yes.
Today is time to talk about that.
Until one meeting, what I said, I explained it.
So those are photos from meetings and.
This is from Galati in Romania meeting from last September. Also, last left one is. In Galati, there is also botanical garden. We had a chance to visit Galati Botanical Garden. And in Galati, there is our supervisor of Galati University, Professor Rodika Pinica. Thank you very much, Eddie. He is giving a certificate to Valentin Çevanov for her speech. You can see in the middle of photo. Last one is all about from our laboratory. This is freeze drying. We are drying our samples in freeze dryer. This is better than room temperature drying. You can keep your compound without composition, without any problem. This is again from Galati.
It is in Prague, I guess, right?
Not Prague. This is from Italy, okay. Prague will be soon. Maybe we don't forget to put photo, but we will see.
Well, so GreenChem project aimed to protect medicinal plants through green chemistry, addressing climate change, pollution, and public health challenges. Regionally, it has supported biodiversity, accelerated economic growth, and encouraged academic business collaboration. Globally, it has contributed to efforts against climate change and biodiversity loss by promoting sustainability, raising awareness of medicinal plants, and promoting green technologies. And this is another photo from Italy. And we're going to end our session. But before that, I'd like to thank my team, who are Mr. Ali Bebish and Mr. Hakan Tashkaya. So they helped a lot of us because it was a combined project conducted by BTechMer and Erasmus Plus coordination of this. So welcome again. So
I read, yes, I say some speech, and I want to say to this year's previous meeting, third meeting, it will be in Prague, in Chemistry and Chemical Technology University of Prague. This university focusing all five fields of chemistry. What they say sometimes, they are the biggest chemistry university in Europe. We can say like this, like we say in Artvin, we have the biggest, most biggest study in the world. We say, like we can say also, their university is focusing chemistry all field very
you should be proud of your university.
Yes, and also this university is only focusing chemistry. You can say if you compare other universities, maybe can be little university, but they have from all fields they have very important, very good quality, high quality scientists. One of the scientists from Radek Çubuka and Professor Radek, and another one is Martin Kuhar. Martin Kuhar is focusing on analytical part of our results. You will, after lunch, you will see in this result. And Radek also focusing about photochemistry. They are also very good. We also their effort is very good for project. And also I want to introduce Valentin Çevanov and Bitkilerde. They are from Ukraine, and we are very long period collaboration, maybe 15, not maybe 13 years before we started. And they are also very good professors about organic chemistry, green chemistry. I learned from them too much.
Thankfully, you will be sharing this session.
Yes, And thank you very much for all our participants for this project. And I want to say also thank you all our guests, our professors, our students, and all the people. Thank you. Thank you.
Special thanks to our academic coordinator, Associate Professor Dr. Mustafa Kemal Gümüş. Now, if you please allow me, I would like to introduce you our Deputy Rector, Professor Dr. Murat Kibar. He will be addressing to you as an opening speech. Please come on.
Ladies and gentlemen, welcome to Turkey and in our city, Artvin. I wish to success Symposium. 11 farklı ülkeden katılımcıların olduğu Avrupa bölgesindeki seçilmiş tıbbi ve aromatik bitkilerde Yeşil Kimya Uygulamaları Uluslararası Sempozyumuna hoş geldiniz. Bugün çevremizin ve halk sağlığımızın karşı karşıya olduğu en acil sorunlardan bazılarını ele almak üzere Avrupa ve Asya'dan uzmanları bir araya getiren ve önemli bir küresel etki yaratan bu önemli etkinliği sizlerle gerçekleştiriyor olmaktan gurur duyuyoruz.
Distinguished guests, researchers, and valuable participants, I would like to welcome all of you to the International Symposium on Green Chemistry Application in Selected Medicinal and Aromatic Plants in the Artvin region, with participants from 11 different countries. As the Vice Rector of Artvin Çoruh University, I am proud to be organizing this important event with you, bringing together experts from Europe and Asia to address some of the most pressing issues facing our environment and public health today, and making a significant global impact.
Bu sempozyum İtalya, Romanya, Çek Cumhuriyeti, Ukrayna ve Gürcistan'dan ortaklarla birlikte yürütülen Erasmus Plus projesinin bir parçasıdır. Bu projeyle tıbbi bitkilerin özellikle de bu bölgeye endemik Hypericum ve Ruscus Türlerinin kullanımı için sürdürülebilir ve yenilikçi yöntemler geliştirmeyi amaçlamaktadır. Amacımız biyoçeşitliliği korumak, çevre dostu uygulamaları teşvik etmek ve hem bölgesel ekonomik büyümeye hem de küresel çevresel sürdürülebilirliğe katkıda bulunmaktır.
This symposium is a part of our Erasmus Plus project, Green Chemistry Applications in Selected Medicinal and Aromatic Plants in the Artvin region, which we are carrying out together with partners from Italy, Romania, Czech Republic, Ukraine, and Georgia. With this project, we aim to explore sustainable and innovative methods for the utilization of medicinal plants, especially Hypericum and Ruscus species endemic to this region. Our aim is to preserve biodiversity, promote environmentally friendly practices, and contribute to both regional economic growth and global environmental sustainability.
Proje sadece yeşil kimya alanındaki bilimsel bilgiyi ilerletmekle kalmayacak, aynı zamanda bitkilerin iklim değişikliğiyle mücadelede, çevre kirliliğinin azaltılmasında ve halk sağlığının iyileştirilmesinde kritik rol oynayacaktır. Bu proje hem yerel hem de uluslararası düzeyde pratik, uygulanabilir çözümler sunarken küresel sorunları ele alan ve bize daha parlak, daha yeşil bir gelecek için umut veren araştırmaları teşvik etme taahhütümüze de uygundur.
The project not only advances scientific knowledge in the field of green chemistry, but also emphasizes the critical role that plants play in combating climate change, reducing environmental pollution and improving public health. This project is in line with our commitment to promote research that addresses the global issues while providing practical, workable solutions both locally and internationally, giving us hope for a brighter, greener future.
Proje ortaklarımızın, araştırmacılarımızın ve katılımcılarımızın her birine değerli katkıları için içten teşekkürlerimizi sunmak isteriz. Bireysel çalışmalarımız daha yeşil, daha sağlıklı bir geleceğin yolunu açacaktır. Bu sempozyumun ilham vereceği tartışmaları ve sonuçları dört gözle beklemekteyiz.
I would like to express my sincere thanks to each of your project partners researchers, and participants for their valuable contributions. Your individual efforts are paving the way for a greener, healthier future, and I look forward to insightful discussions and outcomes that this symposium will inspire.
Bir kez daha Artvin'e hoş geldiniz. Bu sempozyumun öğrenme ve gelişme için muazzam bir platform olacağından eminiz. Verimli ve zenginleştirici bir deneyim yaşanması umuduyla saygılar sunarım. Hoşça kalınız. Başarılı bir sempozyum tekrar diliyorum.
Once again, welcome to Artvin. I am confident that this symposium will be a tremendous platform for learning and development. I hope you have a fruitful and enriching experience. Thank you very much. Thank you again, Professor Dr. for his excellent speech. And now it is time for inviting our precious and valuable keynote speakers. I would like to begin with our international partner who is coming from Ukraine. Professor Dr. Artvin Çoruh will be chairing this session. So, Professor, could you please come over and have your say?
Dear colleagues, it's time to start our lectures, and our first speaker, keynote speaker, Professor Dr. Artvin Çoruh. He was born in Istanbul in 1973. He graduated from Samsun on the Mayıs University, Faculty of Agriculture, Department of Field Crops in 1995. He completed his master's degrees in 1998 and his doctorate in 2006 at the Field Crops Department of the Institute of Science and Technology in the same university. In 2008, he received his title of Associate Professor in the Department of Industrial Plants, and he was appointed as a lecturer at this university. He became a professor in 2014. He still continued to work as a lecturer of the aforementioned institution, and it's a pleasure for me to invite him for the lecture.
Dear participants, welcome to the GreenChemMap application in Medicinal and Aromatic Plants, Hypericum and Ruscus Species Symposium. Be sure that I am very happy today to be here with you, my distinguished colleagues, and I must also indicate that I am very thankful to Artvin Çoruh Üniversitesi for the opportunity to give a speech in such a selected and prominent organization. In this opening speech, as a researcher who has devoted almost all of his academic life to examine Hypericum species, I would like to briefly tell you about the Hypericum genus and especially Hypericum bifurcatum. Hypericum is a versatile genus of Hyperaceae family and consists of about 500 species that are herbs, shrubs, or trees and distributed in almost every climate zone of the world. All these species have been used for therapeutic purposes around the world for centuries. Turkey is one of the most important intersection points of the world for this genus. The Turkish vascular flora hosts a total of 119 taxa from the genus Hypericum, and 49 of them are reported to be endemic. The common name of Hypericum taxa in world literature is St. John's wort. Hypericum bifurcatum is the most common and the only pharmacopoeia included member of the genus Hypericum. It's a perennial herb originating from the arid regions of Europe and North America. The medicinal of this plant date back 2,400 years ago, and especially its own healing effects have been known since the 5th century BC. In the 1st century AD, famous Greek physicians Yeşil and Dioscorus described this plant as a diuretic and oil-healing herb and recommended for the treatment of menstrual disorders. Interestingly, this plant have a very interesting historical background. With the spirit of Christianity, the plant became associated with Saint John Baptist, who is known by Muslims as Saint Yahya. According to the Gospel of Matthew, John lived in Palestine and people were baptized by him after confessing their sins. That is why he was known as John the Baptist. However, John the Baptist had a disagreement with King Herod and was first imprisoned and then executed by beheading. According to the belief, the next day following the execution, St. John's bird flowers were seen at the place where John's blood was shed. From that day on, it was believed that the red liquid found intensely in St. John's bird flowers was John's blood, as shown in the pictures. Due to these beliefs, many mystical and sacred properties have been attributed to the St. John's wort plant, and people have used Hypericum plants as a talisman to protect their souls from demons for centuries. Famous English herbalist Artvin Çoruh indicate that American Indian tribes have used Hypericum species as antipyretics and cough medicine for centuries. Europe described the ointment he prepared using this plant as the best known and most effective wound-healing medicine. In his list of medicinal plants prepared in 1633, Europe recommended this plant balsam against burn, wounds, ulcers, and snake insect bites. Similarly, the other famous British botanist, herbalist, and physical Nicholas Culpeper pointed out that the beneficial properties of herb against stings and bites of poisonous animals. Since the 16th century, the essential oil distilled from the aerial purple plant began to be used as a wound healer in Europe greatly. This oil was so effective that surgeons not only used it to clean wounds, but also included it in Europe's first official pharmacopoeia under the name of Hypericum. By the 1800s, decoction prepared from Hypericum perforatum was used to remove inflammation and some in urinary tract and to treat kidney stones, cuts, and rheumatism. This decoction has also antipyretic and intestinal papers and reducing effects. American pharmacists verified reported that Hypericum perforatum oil could be used internally and externally in the treatment of ulcers and cancer. The other American pharmacist King mentioned the internal use of Hypericum perforatum in treatment of urinary pains, inflammation, and depression, and externally in the treatment of physical traumas in the American Codex he prepared. In the updated edition of this codex, 22 years later, Fenton and Lloyd recommend Hypericum perforatum tincture for the treatment of spinal disorders, physical shocks, concussion, and hysteria. In the last century, the world-famous herbal botanist James II compiled the formulary use of Hypericum perforatum in treatment of ovarian polyps, uterine cancer, stomach cancer, and lymph tumors in his handbook of medicinal plants. Similarly, the famous American anthropologist and ethnobotanist Daniel Mormon stated that Hypericum perforatum was used by the Cherokee, Montana, and Iroquois Indians as an antipyretic and to prevalent infertility in his ethnobotanical dictionary, describing 3,000 plants used by Native American tribes for medicinal purposes. Today, the annual sale value of Hypericum-based antidepressive pharmacological products and food supplements in different forms exceeds $100 million in Europe markets and $500 in USA, and it has reached nearly $1 billion worldwide annually. Hypericum extracovial constant plants are reported to contain 6 major molecular product groups, namely naphtholion known as Hypericum and pseudohypericum, fluorogenol derivatives, hyperforin and hyperforin, flavonoids, camphorol, butyrylin, quercetin, etc., biflavones, abidinin and amantaflavon, phenil, propones, chlorogenic, neochlorogenic, and fatty acids, and proanthocyanins, especially as tannins. Additionally, listed number xanthans, sensuals, and amino acids are present. Among the many bioactivities of Hypericum is that the antidepressant, antiviral, and anti-cancer effects are mainly attributed to the Hypericum and Hypericin, as well as some other analogs as rutin and quercetin, and the wound-healing effects are attributed to the essential content. Over the past 40 years, Hypericum plants, especially Hypericum bitroitum, have been extensively investigated in clinical and laboratory studies. The results have revealed strong antidepressant, antiviral, anti-cancer, wound-healing, anti-inflammatory, antibacterial, and antifungal effects for Hypericum plants. I will talk briefly about the results. First, antidepressant effects. There are many clinical and experimental studies on the effectiveness and reliability of the antidepressant activity of this plant. In these studies, different Hypericum extracts were compared with placebo, tricyclic antidepressants, and selective serotonin uptake inhibitor group standard drugs. Results briefly indicate that Hypericum extracts are significantly more effective than placebo and at least as effective as tricyclic antidepressant and SSRI group drug in treating depression. Besides, the frequency of side effects of Hypericum extract is extremely low when compared to standard antidepressant drugs, which further increase the importance of the plant in treatment of depression. Antiviral effects. The American National Cancer Institute has been conducting intensive studies on Hypericum species, and according to the results, some metabolites obtained from these species show very severe antiviral effects. Particularly, hypericin and pseudohypericin are very effective against DNA and RNA viruses. It has been reported that these substances are very effective in preventing infections caused by many viruses and specifically the HIV virus. Anti-cancer effects. Hypericin and hyperforin, the main Hypericum chemicals, prevent cancer formation and development by causing programmed cell death in different cancer cell lines. The plant has a special importance in treatment of prostate cancer. So, studies have shown that Hypericum perforated mineral extract prevents the growth of cancerous cells by blocking serotonin uptake and kills these cells with the cytotoxic effects of the chemicals that contain, namely hyperforin, hypericin, and quercetin. Therefore, the plant is a promising alternative in treatment of advanced stages of prostate cancer. Wound-healing effects. The most common pharmaceutical reason for all this plant is Jones rheumatoid, the macerate prepared by soaking the flower tops in olive oil. And there are a number of reports documenting the science the significant wound-healing effect of bottle, this oil, and different plant extracts in the Çoruh literature. When St. John Mortal is mentioned, this must come to mind rather than essentially distilled from flowering tops. Anti-inflammatory effects, medicinal extract of Hypericum reflection, for example, an endemic species from Canary Islands, was reported to reduce significantly the artificially induced pain and erythema in mice. Antibacterial effects. Cured plant extracts prepared from aerial parts have a severe antibacterial effect due to the essential oil they contain. There are many studies reporting that these extracts can be used in treatment of bacterial wounds and infectious diseases, especially in bacterial regional infections. And the fungal effects. Several native Hypericum species have been used in Brazilian folk medicine, for example, for centuries in treatment of mouth sores and sanitation diseases. Studies have reported that medicinal extract of these plants show strong antifungal effects against the pathogenic microorganisms, namely Staphylococcus aureus and Lichen albicans and Tritophycon rhabdum. And what about us and our studies on Hypericum genus? Our research group consists of the researchers from 3 universities of Turkey, namely 19 Mayıs University, Recep Tayyip Erdoğan University, and Gaziantep University, and two institutions from the abroad, namely Institute of Ordinary Aromatik and Bizi University from Italy. For the last 20 years, we have been carrying out different studies on the morphology, city conservation, cultivation and domestication, population dynamics, chemistry, chemosystematics, and biotechnology of different Hypericum species from Turkish flora as a research group. Today, we have determined the phenolic and volatile components of 119 species from Turkish flora. We defined an immediate propagation protocol for 4 of them, and a germination protocol for 11 of them. We managed to cultivate 3 of them under field and greenhouse conditions. Thus, we have produced nearly 90 articles on Hypericum published in international scientific journals. In my opinion, it will be insolence to talk about these studies one by one in the presence of you, our valued participants. Therefore, please let me briefly introduce to you the Hypericum species we have been examined so far, rather than mentioning our publications. Let's take a look at these species. First, of course, Hypericum perforatum, the most common, well-known and pharmacologically included member of the genus. We have conducted several studies on this plant so far. For example, we sampled many of plant populations to reveal the chemical and morphological variations among them. We germinated the seeds on open seedbeds and carried out some studies by growing the seedlings under both greenhouse and field conditions. Also, we have developed an effective nuclear propagation and secondary metabolite production method for this species. I must indicate that many of our studies on Hypericum perforatum are first for Turkey. Now, after the very famous Hypericum perforatum, Saint-Jean, I would first like to talk about the endemic ones. Hypericum avicularium subspecies develendum. This endemic species has some interesting morphological and chemical features. For example, as shown in the picture, all the aerial parts were covered by black glands, and we detected a positive and significant relationship between the hypericin content and dark gland numbers of leaves. Interestingly, Hypericum and essentially the other 2 secondary metabolites of Hypericum plants, their contents were also related with the dark gland number of leaves. You see, it's a different kind of dormancy, therefore it's very difficult to propagate the plant with seeds. Thus, we developed an nuclear propagation method for the extended conservation of this endemic plant. And other subspecies of the same endemic species, subspecies avicularium, it's very similar to the previous one, both morphologically and chemically. Hypericum organiform variety developum, again, morphologically very similar to the Hypericum avicularium. Hypericum pisophypholium and Hypericum heterophyllum, both are small and creeping herbs. In Hypericum heterophyllum, although we tried many different methods, we couldn't germinate the seeds. Thus, we also developed an individual propagation method from this plant parasitic conservation. Hypericum confectum. This endemic species grows at altitudes of 2,000 meters and above, and this distribution area is quite limited. For this reason, it was very difficult to find the plant in this natural environment and take the samples. Hypericum lactophyllum. Unlike the other endemics, it is possible to encounter this species abundantly in the campus area of Ruscus Türleri University of Turkey. Hypericum cardiophyllum. This endemic plant was also very interesting because even though we visited an area of 10 or square kilometers for 2 days, we could only come across a few plants in just one population near the Turkey-Syria border. Hypericum capitalium variety capitalium. The most fascinating Hypericum plant I have ever seen was definitely this endemic species. As you can see, the red flowers look really great and magnificent. Hypericum capitalium variety Uturum. This is another variety of the same endemic species. The only difference between them is that their flowers are yellow, not red. Hypericum elongatum variety Litifolium, the taller one, and Hypericum elongatum variety elongatum, the shorter one. Two varieties of the same endemic species. Hypericum sansarifolium and Hypericum spectable, the last endemic one. I should indicate that there were no reports on the chemistry of these endemic species in the scientific literature until we examined them. The species I will mention next are not endemic but have attracted relatively little scientific attention so far. First, Hypericum plevoides. This species is very rare and its distribution area is quite limited. Thus, we also developed an unique propagation method for acidic conservation, as shown in the picture. Hypericum plevoides. This is also very interesting one because, unlike many other Hypericum species, it grows in wetlands and rather than dry areas, and it sees a very high germination rate. In the flow system, especially the development tobacco segment production, Hypericum plevoides seeds germinate very well and became seedlings. It's possible to get successfully transfer these seedlings to pots, as shown in the picture, and to grow the plants under greenhouse conditions. It is also interesting to note that immediate propagation was not possible without a careless interface in the species I mentioned above. However, systemic experience of Hypericum plevoides exhibit direct shock regeneration without forming careless. Hypericum medium, unlike the others, the inflorescence of this species resembles as a pyramid. Hypericum monochromatic. Hypericum oriental, a species that grows entirely among rocks as shown. Hypericum tilcoreidum, a species currently used in the treatment of earache in children, especially in Europe. Hypericum scabrous. In Anatolia, a wound-healing ointment is prepared from the lower and upper part of the species for centuries. Hypericum naviginosum, a very rare species from southern parts of Turkey. And Hypericum ruscingere, this is also a very rare species, not the previous one. Hypericum oliveri, as its Latin name suggests, the flowers of this plant smell like olives. Similarly, the flowers of the plant, Hypericum thymifoilium, also smell like thyme. This is possibly related to the essential composition of both species. Hypericum hirsutum, as shown in the picture, the plant is named in what literature as hairy Saint-Jean's word. Hypericum linearioides and its colorful and fascinating flowers. Hypericum linearioides, morphologically very similar to the former. Hypericum trichatelifolium. This is a common species in Turkey and throughout the Middle East. We also managed to cultivate it in pots under greenhouse conditions. Hypericum reticum, morphologically very similar to the previous one. Hypericum polyphyllum, a species from very high elevations. Hypericum palens, a magnificent species again. It is attention that the black dots densely covering the floral parts indicate high hypericum content. Similarly, Hypericum botanicum, again, the floral parts were covered intensively by black dots, which are main organs for hypericum synthesis. Hypericum venustum, in the last species, the floral parts were again densely covered by black glands. Interestingly, the only species yielding black glands are reported to contain hypericum from regional variety. The species I have mentioned so far, both endemics and the others, were herbaceous, but the last four are shrubs. First, Hypericum hircinum, and its magnificent and large flowers. Hypericum caricinum. Interestingly, the shiny leaves and especially the flowers of the species are quite large, as shown in the picture. Hypericum and Ruscus, it is an evergreen shrub and commonly known as Tütsen. After the world famous Hypericum purpureum, it's a promising medicinal plant with its well-documented different kinds of bioactivities. It should be noted that in the genus Hypericum, the fruit type is generally capsule-shaped and has a pyramidal appearance as seen in the example of Hypericum purpureum. But Hypericum and Ruscus has unique non-granite flesh-shaped fruits that are green at first and then turn shiny red to black during ripening. Interestingly, the natural fruits have recently been recommended as a herbicide due to their high content of antioxidant compounds against effective aging. And the last one, Hypericum piscinestifolium. This species is very similar morphologically of the previous one, thus commonly known as Turkish Tütsen in worldwide. That is all. I briefly introduce you to Hypericum plants and tell you about the species I have examined so far, most of which are endemic. Thank you for your listening and your valuable participation. You are welcome again.
Thank you very much for the lecture. The next speaker today, Professor Fatih Seyis, was born in 1969 in Trabzon, Turkey. He lived 12 years in Germany and first school and gymnasium, and went back to Turkey in 1984. After 1987, he finished his education in Turkey. He began his education in agriculture engineer and the Faculty of Agriculture of Ruscus University. In 1994, he finished his Master of Science degree also in Samsun. During 1997-2003, he finished his PhD work in Ruscus Türleri University, Institute of Plant Breeding in Yeşil, Germany. In 2004, he went back to Turkey and attended as assistant professor, doctor in 2004, and as associate professor, doctor in 2006 at the Faculty of Agriculture in Ruscus University, Samsun. In 2010, he switched to the Faculty of Agriculture in Bozok University. In 2013, he went to the Faculty of Agriculture in Recep Tayyip Erdoğan University, Bizi. He works in the field of plant breeding and biotechnology. He has concentrated his work in the last year on the medicinal and aromatic plants in the Black Sea region. It's a pleasure for me to invite him for the lecture.
Thank you very much, Professor, for the nice introduction. As you have listened from the introduction of myself, I grew up in Germany. Therefore, you will be not surprised that the Turkish guy is speaking with a German accent in English. Sorry for that at the beginning. So I have asked for a microphone because I have to be mobile here. Okay. Dear distinguished guests, it's a pleasure for me to present our work, which we have done with my handsome colleague, Professor Dr. Çoruh, during the last 10 years. First of all, again, I want to take the opportunity to thank the organizers of the symposium for their invitation for this very pleasant symposium. I think there will be a lot of collaboration between all of participants. And I will talk about the discrimination of chemical constants in different species using chemical analysis and the more familiar principal complement and people analysis. But first of all, sorry about that again. Okay, I will introduce my small working group at the Recep Tayyip Erdoğan University. You can see it's me. Emine Yurteli, Assistant Professor. Aysel Özcan Aykutlu, Research Assistant. She finished their work last year about the use of organic fertilizers in tea cultivation in the Black Sea region. And Haydar Köprümez is working about team species distributed in our region. So, as I said, it's a pleasure for me to present our work. The colleagues here, Mustafa and Umut, contacted us and asked us what can we here present about our work, and therefore we decided that Cüneyt give a brief introduction about the biological species and me complete his speech about the usage of different techniques in the discrimination of the species. So, I think a lot of people here in the audience are most familiar with GCMS and HPLC, and therefore I will switch to a small introduction. I will talk about principal component and byproduct analysis. I have to mention here, during my PhD work in Germany, I was first familiar during my PhD work. I worked about use of interspecies species, the use of interspecies species of increasing genetic variation in grapes in Brassica napus, using traditional methods. You know also, you have to discriminate them in on morphological level, on the field, on molecular level, and also on fatty acid composition, etc. I will make some recommendation about software and the conclusions. As the beginning of our teamwork, we worked with Italy and Lithuania because the cost of this equipment is very high. Only this slipper device here on this upper part cost $66,000. It's a very high price in Turkey. And this lower part, the main unit, costs about $70,000. And I will here thank Doka, it's a local development agency, which supported us to buy these two devices. The GCMS supported with the CPMA device and the HPLC chromatographic system. So, what we have done, I will talk first about the principal components. All of people who are familiar with statistics, you know the correlation analysis. You will calculate positive or negative interactions between two topics of interest. You have a triangle. What is the principal component doing? They plot it on the second level. You have a rectangular space here, and you can communicate on each part of this. But the history of this, Carl Persson introduced this method in 1901, about 120 years ago, and you can use it also nowadays on an effective level. Yeah? And principal component analysis is mostly the most widely used and well-known of the standard multivariate methods. After that, I will switch to bipart analysis in our work. What means principal component analysis? If you have 10 characteristics for ourselves, 10 different chemical groups, 10 different morphological or phenological traits, the system is calculating, if you have 10, is calculating 9 principal components. It's calculating 9 different principal components, and the first principal component displays the present evaluation based on the interesting components and plotted on a graphic level. So, and the first principal component and the second one and the third one, you can use them to create 2-dimensional or 3-dimensional graphics also. So, during my PhD work in Germany, there was a statistical program. The price of this program was 15,000 euros. Also high prices. We are using in Turkey SPSS data, MATLAB, JAMP, and Excel. And I will recommend Excel in the first slide, and then we will give the reasons for that. There are a lot of work, papers, book chapters about principal component analysis. You can see generalized linear model, multi-dimensional model, etc. I have used principal component analysis biparts in our work. So, this principal method can be used beginning from agronomy to botany to anthropology in all fields. The first use of them was in ecology also. In our working area, for example, in field crops, you can create also genetic environment biparts on an effective way. Now I will begin with our work. As I mentioned, it was the best way to present our work with my colleague Julie. The first manuscript I want to mention is we have collected different Hypericum species from the Rasant and Olympus. And here we separated them in flower parts, in leaf parts, and stem parts. And during our manuscript, you can see the evolutionary process of our chemical analysis and our statistical analysis also. This is a principal plot diagram. Here we can see the biparts because SPSS up to 10 years ago we were not able to create biparts. Now we can do it. And the next paper, you can also create diagrams. If you go back to the first slide. Using the principal component analysis, we were able to differentiate flower parts from these different Hypericum species, from the leaf and stem part. Of course, the next step will be the molecular characterization of the species. So, the next work is also about the circumferential plants of different Hypericum species in Turkey, done with the working group in Lithuania. So, again a principal component plot. You can see here the principal components 1 and 2. Here the percentage of created by first components. Here are 37% and here 28%, about 60%. It's a very good percentage to display the main present chemical variation in our work. So, the next one, here we have the altitude. I'm coming from the Yeşil region, from Bizi, the capital town of rain in Turkey, and it's a very hilly area. I worked on oil plants in Samsun and in Yozgat, but in Bizi we have no flatland. Therefore, we decided to switch to the medicinal and aromatic plants, and beginning from the coast up to the highlands, there are different species, Hypericum species in this area, and I switched to Bizi in 2013. There were only determined 3 Hypericum species, and now there are about 12, because we have made together a lot of collection files in this region. So, these 2 parallel species, Androsianum and Polyphyllum, we collected them from different altitudes, and we have seen that also we can differentiate these 2 species based on the chemical composition using the principal component analysis method also. So the next one. So sometimes we are speaking about essential oil, volatile oil. We had a lot of problems with publishing our manuscript because the editors or the reviewers say, okay, if you are a CPR, you have to talk about volatile secondary metabolism, therefore the determinations are very different. Okay, so here we have Hypericum convertum, lithium and orientale collected from different altitudes, and you can see here every species would be differentiated, discriminated from the other based on their volatile oil composition. And also the dendrogram, which based on the calculated principal component of factor analysis, show the same situation as displayed in the Goldman graph. Now, Hypericum perforatum, it's a prominent number, as all of you know, and here, sorry for that, I have a small problem here, okay? Effect of altitude on Hypericum perforatum. Here on the left side we have the HPLC analysis of different secondary metabolites, and here the GCMS analysis, where you can see the different we have numbers of beginning from hierarchy, routine, classical, and so on. And here we have the chemical groups, as mentioned in a lot of papers. You can see that in both chemical classes we can differentiate the material based on their artificial correction sites. So, again, the dendrogram shows us that from different altitudes we have, as expected, different chemical compositions. So, the next step was to collect the plants based on their ontogenetic variability. Here you can see Androsyabum on the left side and Xylostophyllum on the right side. As I mentioned, there are perennial species, beginning from the vegetative period up to the fruit development period. We collected them, and again, using the chemical constitutions, we are able to differentiate the developmental stages of these two species based on their chemical composition. So, this was Hypericum androsyabum, and here we have Hypericum xylostophyllum. Another work, another species, Hypericum auriculatum, subspecies depilatum, variety depilatum. My colleague showed this plant also very nice pictures about this plant, and here we have the byproduct. What means byproduct? I mentioned that we differentiate on the chemical level. Now we have here arrows beginning from a center point. This means we have here for example, we have here plantate, the secondary metabolites, and this means the numbered genotypes or chemotypes here are different regarding plantate compared to the another one. You can see on the plotting diagram that here, beginning from 0 up to positive, negative values, this means there are correlations, positive and negative correlations, vice versa. So, the next one, as I mentioned, volatile, we changed the determinations because of the editors. Here you can see, again, using white we were able to differentiate different, here maybe 6 different species based on sheer volatile secondary metabolite content. Which will be a key for the next stage for the molecular characterization of this investigated species. So our last two work about 6 Hypericum species in Turkey. In the first one, we have used the HPLC analysis here, and you can see also in the 6 species there are a lot of great variation based on the calculated principal component values. So, summarily to say, these both techniques are useful tools in the differentiation of plant material. Interpreting present data is more efficient and can be used in different disciplines. I mentioned that I prefer Excel stuff. Excel stuff is based on Excel, a Microsoft program. It's very cheap, and you can use on student level, on academic level, and on university level. I have mentioned in Germany the program costs €15,000, and this one costs I every activate my membership about €250. It's very expensive. It is a very effective tool. Therefore, the recommendation. So there are some literature references about some people who have worked about the use of different material, using them using on this pose. Methods. Thank you very much for your kind attention.
Thank you very much for a nice lecture. Colleagues, we have time for questions for both our speakers. If you have, please. No questions? Okay.
Thank you very much. I wanna also ask something and wanna say something. Thank you very much, especially I listen carefully different type of Hypericum types, and we focus only two type of Hypericum, Hypericum androsanum and Xylifolium. About we will see in next lectures about their potential. I want to say thank you for both speakers. They are very high quality scientists around the world, and focusing especially, maybe I am not sure, maybe in Hypericum, maybe they are also focusing over one. And I want to say thank you to Dr. Umut Kıvanç to introduce our partner or team with invited speakers, Fatih Seyis and Cüneyt Çırak Hocam. Thank you very much.
Thank you, Mustafa. So, you have questions, please. No. Okay. Let's engage our speakers for nice presentations.
I want to say, Hakan Gültekin is outside now. He's okay. Now he's done. He can continue.
I was given an interview to the national channel, so I'm sorry, I'm here. So, I guess we are done here for now, for the opening speech. Thank you very much for your patience, but before letting you go, I would like to invite our dear Deputy Director to the scene. We would like to give some special gifts to our guests, our keynote speakers. Jen, could you please come over here? First, I would like to begin with Professor Valentin Chobanov. Professor, could you please come over here?
Professor Cüneyt Çırak. And Professor Fatih Seyis. Thank you.
Here we are ending the opening ceremony, which we have been honored with your participation. The program will go on with lunch, but lunch will be at 1 p.m. So I propose you to gather here before going lunch. The weather is nice, so maybe you will be enjoying our campus. And then, I guess 12:45 we can gather here and go to lunch together. If you please accept my proposal. Thank you so much.